All right, so today we are going to be working with negative exponents. Our learning target is to simplify expressions with negative exponents. So if you recall, we have some rules for simplifying monomial. We have the product of powers, and then we have a to the m times a to the n equals a to the m plus n. So just notice, because they have the same base here of a, you can simply go ahead and add the powers there together and combine those together. So the example there that we have is that we have 5 to the third times 5 to the fourth. So notice they both have the same base. They're 5, so you write that down. And then you simply add the exponents of 3 plus 4 there, gives us 7. So you get 5 to the 7th. And then you could just simply put that into your calculator, 5 to the 7th, to get your solution there. We have another one there. We've got a power of a power. So if you've got a to the m to the nth power, so a power to a power, what you do when you have a power to a power like that is you simply go ahead and you multiply the powers together. So we have 3 to the fourth to the second power, and then you can just simply write down 3, and then 4 times 2 there is 8, so we get 3 to the 8th, and then you could put that into your calculator and find out what 3 to the 8th there was. All right, so now negative exponents. So this is the one we want to look at right now. And this one here, as we're looking at negative exponents there, something you need to know is if it's in the inverse, if it's in this, wherever it is, if it's at the bottom, then you want to move it to the inverse side. So if it's at the bottom, you want to move it up and make it positive. If the negative exponent is at the top, then you want to, and it's negative up there, then you want to move the whole thing down and make the power positive. So for instance here, we have 1 over a to the negative n power there. And so what you do there is you flip it up and you get a to the nth over 1. So you see how I took a to the negative n up? It goes up and becomes positive there. And then a to the nth divided by 1 there is a to the nth. So that's how we end up getting that solution there. So that's how that one went. All right, so now let's look at the next one here. We've got 1 over b the negative 8. So what you do there is you flip it up, because it's negative down on the bottom. I bring it up, and I get b to the 8th over 1, which just gives me b to the 8th. So now what happens if the negative power is at the top or up there in the numerator there? So if it is, then what we end up doing there is we've got a the negative n, so it's like a the negative n over 1. And so you're going to flip it down and make it a positive power. And so then we put a placeholder for 1 up there. So just 1 over a to the n. And you need a 1 at the top there if you just have some monomial down there in the denominator. So let's look at the other one down here. This one here is 2 to the negative 3. And so you're going to take the 2 to the 3 and put it down here in the denominator. And then you can find out what 2 to the 3 there is. So you could put that in your calculator. 2 caret key 3, and it's going to tell you, or it's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So you actually get 1/8. So our next rule for simplifying exponents here, or monomials here, if you've got a power of 0 there, so anything to the power of 0 there equals 1. So 5 to the 0 there is 1. What is x to 0? It is also 1. Now we've got a quotient of powers. So quotient of powers, that means division. So you've got a to the m divided by a to the n. So when we had multiplying a product of powers there, we went ahead and we subtracted the powers. When you've got a quotient of powers, you want to go ahead and subtract them. So when we had a product, we added them. When we have a quotient, we subtract them. So notice you got a to the m over a to the n. We go ahead and say a to the m minus n. So the one down here, we got 4 to the third divided by 4 to the second. You just go ahead and do 4 to the 3 minus 2, which gives you 4 to the first, which gives you an answer there of 4, because 4 to the first power there is just simply 4. So let's start to go through some examples here. We've got 3x to the negative 5 divided by x to the fifth. Now, there is a 1 here on the outside. We don't write it there. So your numbers there, that 3 divided by 1 there is 3. And then we've got this x to the negative 5 here, up here in the numerator there. So we're going to flip it to its inverse side. So we're going to flip it down into the denominator and make it x to the fifth. There's already an x to the fifth down here. It doesn't get moved because it's not a negative power. So now we can simply combine those, x to the fifth times x to the fifth. You go ahead and you add your powers there together. 5 plus 5 there is 10. So you get 3 over x to the 10th. All right, so our next one here, we got 4x to the fifth divided by 6x to the negative 2. So you got 4 divided by 6. So always look to see if you can simplify those down, since I can't divide 4 divided by 6 and make that a nice number there. I just want to go ahead and reduce that down. So what goes into 4 that also goes into 6? Oh yeah, 2 goes into 4. How many times does 2 go into 4? It goes in there twice. How many times does 2 go into 6? Oh yeah, 3 times. All right, so now we have x to the fifth up here, so we're not going to move that. It's not a negative power. And we got x to the negative 2 down there in the denominator, so we're going to move that to the inverse side. So we're going to move that up here to the numerator here and make that a positive power. So now we can leave the 2/3 there alone, because it's already reduced as much as possible, and we can combine that x to the fifth times x to the second. You add over multiplication, you add the powers there together, so we get x to the 7th. All right, so now I've got 32x to the negative 6 over 20x to the negative 4. So we can reduce that down. You gotta think about what goes into 32 that also goes into 20, and I'm thinking, oh yeah, 4. So we have this 32x to the negative 6 all over 20x to the negative 4. I'm gonna reduce down that fraction of 32 over 20, thinking about what goes into 32 that also goes into 20. That would be a 4. How many times 4 go into 32? 8 times. How many times 4 go into 20? That'd be 5 times. I've got x to the negative 6 up there in the numerator. So I'm going to bring it down in the denominator and make it a positive power. X to the negative 4, I'm going to move that to the inverse side, so I'm going to move that to the numerator up there. So notice 8/5 cannot be reduced down any farther. I always look at that to make sure I did as much as possible. Now I do this, I do the higher exponent minus the lower exponent, so it's 6 minus 4 is 2, and there's more of them down in the denominator down there, so it becomes x to the second is down here. Some people will do 4 minus 6 gives you negative 2, so you get x to the negative 2 at the top, but then you have to flip it down into the denominator and make it x to the second. So either way works. So this next one here, there's like a 1 here in the front. I don't need to write that 1. X to the negative 6, I can bring it down and make it x to the 6. Now notice x to the 4th there is positive, so it's not going to move. It's going to stay down here. I need a placeholder up here, so I'm going to put a 1 up there. I can combine x to the 6 and x to the 4th, adding those together because you add them over multiplication, so you get x to the 10th. So down here, x to the negative 5 there is going to go down into the denominator. x to the, or y to the negative 6 is going to come down and become y to the 6th. X to the negative 2 is going to flip up, become x to the 2nd. Y to the negative 7 is going to flip up, become y to the 7th. Subtract my exponents, 5 minus 2, there's 3. There's more down here in the denominator, so x to the 3rd is going to stay down here. And then y to the 7th divided by y to the 6th there is y to the 1st. And that's up there in the numerator, which is just y or y to the 1st. So you get y over x to the 3rd. B there, we've got x to the negative 6 is going to come down and become x to the 6th. X to the negative 8 is going to flip up and become x to the 8th. Y to the negative 10 is going to flip down and become y to the 10th. And then you got a positive power down here, so it's just going to stay down here. So now over division, we have x to the 8 divided by x to the 6, so we can subtract those power. 8 minus 6, there's 2, so you get x to the 2nd up here at the top because x to the 8th is larger. The larger exponent is where we're going to put our answer. And then y to the 10th times y to the 2nd there, you're going to add them together over multiplication. So adding those y powers there together, you get y to the 12th. All right, so this one here, notice we have a power to a power here. So I'm just going to leave the numerator here alone for a minute here. And I'm going to do this power to a power thing. So you got 2/5 to the 2nd power, so you got to take both the 2 and the 5 to the 2nd power, which gives us 4/25. Because 2 to the 2nd power is 4. 5 to the 2nd power is 25. X to the negative 2 to the 2nd power is x to the negative 4. And you got y to the 4 to the 2nd power gives us y to the 8th. So now I've just got 2 over 4/25. X to the negative 3, I'm going to move down and become x to the 3rd. Y to the 4th is going to stay up here. X to the negative 4 is going to flip up and become x to the 4th because it's the negative power. And y to the 8th is going to stay down here because it's a positive power. All right, so I'm going to combine my x's. X to the 4th divided by x to the 3rd is just x to the 1st, which is up there at the top. Y to the 4th divided by y to the 8th. I'm going to subtract my powers. 8 minus 4 is 4, so there's more down at the bottom, so I'm going to put my answer down here in the numerator, so I get y to the 4th. Now you've got this 2 over 4/25. I'm going to come over here and kind of show you how to do that. So that's 2 divided by 4/25, which is the same thing as 2 times the reciprocal of 25/4. So now I can either multiply my numerators multiplied to my denominators, or I can reduce it down as we go. So if I reduce down my 2 and my 4 here, 2 goes into 2 here once, 2 goes into 4 here twice. So I get 25 over 2. So that means up here, I get 25 over 2. So let's look at the next one here. We've got 3x to the negative 5 divided by 1/4, and all of that is to the negative 1 power. All right, so we could think about, because it's to the negative 1 power in there, everything could be taken there to the negative 1 power. So maybe we'll just do that. Probably easiest when you've got a power there on the outside to take everything to that power. So it's like 3 to the 1st power out there. So 1 times negative 1 there is negative 1. X to the negative 5 to the negative 1 power is negative 5 times negative 1 is 5. So you get x to the 5th. And then you've got 1/4 to the negative 1 power. So now all the negative powers, I'm going to flip to the inverse side. So 1/4 is going to come up, become 1/4 to the first power, which is just 1/4. And then we still have x to the 5th. And then 3 to the negative 1 is going to flip down and become 3 to the first, which is just 3. So now if I can't do anything, I can't simplify the variables any farther, but I can certainly simplify that fraction divided by that number. So if you think about it, it's 1/4 divided by 3, which is the same thing as taking 1/4 times the reciprocal of 3. What's the reciprocal there of 3? Well, you just flip it so it becomes 1/3. So then over multiplication, you multiply your numerators, multiply your denominators. So really we get 1x to the 5th divided by 12. So the 1 of that 1/12 is going to go up by the x to the 5th. The 12 is going to go down at the bottom there. So it just becomes x to the 5th over 12, because I'm not going to write the 1 there in front of x to the 5th. So there we have it. All right, so then the next one there says 3x all to the 0 power. Remember how we said everything to the 0 power there is 1? So our solution there is simply 1. But the next one there just says 8x to the 0 and y to the 5th. So only x to the 0 there is to the 0 power there, or x to the 0 is the only thing that it says, x is the only thing there with a 0 power. Everything else has a different power. So 8 is just 8. X to 0 there is 1. And we have y to the 5th. Well, there on the outside, we can just multiply our regular numbers there together. So 8 times 1 there is 8. And then we have y to the 5th. So as I'm looking at this problem, example 5, a example there, I see I've got some that are power to a power there. So like that 8x to the 5th, y to the negative 4 is all to the second power. I'm going to go ahead and take the power to a power there first. So I'm leaving everything else alone. So I've got x to the 5th to 2nd, power to a power gives me x to the 10th, because you get to multiply those. Y to the negative 4 to the 2nd there is negative 4 times 2 there is negative 8. And then it's not a power to a power down here, so. All right, so now I'm going to start to combine some things. At the top there, I've got just a plain 4, so it's not going to move. 8 to the 2nd there is 64, because 8 times 8 is 64. Now I'm going to move my negative powers there. So x to the negative 3 is going to flip down, become x to the 3rd. Y to the negative 2 is going to move down, become y to the 2nd. Already took care of 8 to the 2nd. X to the 10th is a positive power there, so I'm going to leave that as x to the 10th. Y to the negative 8 is going to move down and become y to the 8th. All right, so down in the denominator down there, the 20, I'm going to move it to the outside here. X to the negative 3, I'm going to move that up, become x to the 3rd. Y to the negative 6, I'm going to move that, become y to the 6th. All right, so now I'm going to start to reduce some things down here. So I've got 4 and 20 there. I can kind of reduce that down. 4 goes into 4 here once. 4 goes into 20 there 5 times. So I'm also going to combine some of my terms here. So far there I have 64 over 5. And x to the 10th times x to the 3rd there, you add your powers there, you get x to the 13th. I've got a y to the 6th up there. Down here in the denominator there, I have an x to the 3rd. And y to the 2nd times y to the 8th. I'm going to add those powers there together, and I get y to the 10th. All right, I can't reduce down that 64 over 5 any farther, so I'm going to leave it 64 over 5. And then I've got x to the 13th divided by x to the 3rd. So I can subtract those powers. There's more at the top there, so I'm going to put the x to the 10th at the top. And then y to the 6th divided by y to the 10th. You subtract the powers there over division there. So I'm going to do 10 minus 6 is 4. And then there's more at the bottom, so I get y to the 4th down here. All right, so then letter B there. Again, I'm going to do my power to a power there first. So 2 to the negative 1. X to the 4th to the negative 1 there. You multiply your power, so you get x to the negative 4. Y to the 3rd to negative 1 is y to the negative 3. These next one here set there in parentheses doesn't have a power to a power, so I'm just going to rewrite them. Down here in the denominator, they have a power to a power, so it becomes 50 to the negative 2. X to the 4th to the negative 2, multiply the powers, you get x to the negative 8. Y to the 5th there to the negative 2, you multiply your powers, you get y to the negative 10. All right, so I'm going to move my negative powers to the inverse side. So 50 to the negative 2 is going to flip up, becomes 50 to the second. 2 to the negative 1 is going to flip down, become 2 to the first, or just 2. We've got x to the negative 4 is going to move down and become x to the 4th. Y to the negative 3 is going to move down and become y to the 3rd. 5 does not have a power, or you can say it's 5 to the first, so it's not a negative power, so it's going to stay there. X is to the first power, it's not negative, so it's going to stay up there. Y to the 4th is a positive power, so it's going to stay in its place as well. All right, so down here we've already moved 50. We've got x to the negative 8, so it's going to move up and become x to the 8th. Y to the negative 10 is negative, it's going to move up and become y to the 10th. All right, so 50 to the second power there is 50 times 50 there, which is 2,500. I'm going to combine my x's up there in the numerator up there. So x to the 1st times x to the 8th. And remember, if you don't see it there, if it's not a power there, it's a 1. So if I combine those, x to the 1st and x to the 8th there, I'm going to get x to the 9th. Y to the 4th times y to the 10th, I'm going to add those powers and I get y to the 14th. All right, so let's keep going here. We got the x's here to combine. I've got x to the 9th divided by x to the 4th there. So over division there, we always subtract our powers. So subtracting our powers there, 9 minus 4 there is 5. And so we end up there getting x, and there's more at the top there, so I get x to the 5th. And then y to the 14th divided by y to the 3rd, you subtract your powers there. There's more y's at the top there, so that's y to the 11th. 2,500, if I reduce that down there with 2, two goes into 2,500 there. 1250 there, 1,250. So then I can take 1,250 there and just multiply it by 5 there, and I'm going to get 6,250. And there's like a 1 down here, so I don't need that. So I get 6,250, x to the 5th, y to the 11th. So I've got 2 examples down there for you to do, so you can go ahead and just pause the video and work through those. All right, so I'm going to go through these. So looking at the 2 down here, I'm going to go ahead and reduce down this 15/10. 5 goes into 15 there 3 times. 5 goes into 10 there twice. So I get 3x to the 2nd. I'm going to bring up x to the 4th. This is a negative power. I've got a y to the negative 7 at the top there, so I'm going to go ahead and bring him down there. And I still have a y to the 1st down here. So now I can just combine everything up there in the numerator there. I get x to the 6, because you have to add your powers over multiplication. Down here, I just have y's down here in the denominator, so I can just go ahead and add my powers there. 7 plus 1, there's 8. So we end up there with 3x to the 6th over 2y to the 8th. So now our next one here, we don't have any parentheses. There's no power to a power in any of these either. So let's just move our negative powers where they're supposed to be. So 3 to the negative 1 becomes 3 to the first, or just 3 down the denominator. X to the negative 4 comes down, becomes x to the fourth. Y to the negative 5 comes down, becomes y to the fifth. X to the negative 7 goes up and becomes x to the seventh. Y to the negative 2 flips up and becomes y to the second. So now we can just combine our like terms there. So x to the seventh divided by x to the fourth. We subtract our powers over division there. There's more at the top, so x to the third is up here. Down in the denominator down here we have a 3 still. And then y the second divided by y the fifth. You subtract your powers. 5 minus 2, there's 3. There's more down the denominator, so it becomes y the third down here. So let's go through this one as well. This one has a power to a power, so let's work through that. Power to a power there, so I've got 3 to the second, which is 9. X to the negative 2 to the second there is x to the negative 4. And y the first to the second there is y the second. And then down here, power to a power there, we get 2 to the third, which is 2 times 2 times 2, which is 8. X to the negative 3 to the third there is x to the negative 9. Y the first to the third there is y to the third. Again, a power to a power, you multiply those. Let's move our negative powers. And I'm going to move my regular numbers next to each other. So I said that 3 to the second there was 9, and I wrote it as 3 to the second. I'm going to move that 9 over here. X to the negative 2. I'm going to move down, and this 2 to the third there is 8, we said. X to the second is going to come down. We've got just a y to the first, and so the y to the first is positive, so he's going to stay at the top there. X to the negative 4 is going to move down, becomes x to the fourth. Y to the second doesn't move at all. It's a positive power, so it's going to stay up there. X to the negative 9 is going to move up and become x to the ninth. Y to the third is going to stay down and be y to the third. All right, I'm going to combine my like terms up there. 5 times 9, there's 45. Because I'm looking at 5 and 9, and neither one of those can go into 8. Or any of its factors there either. So I get 45 over 8. And then I'm going to combine my y's up there. In the numerator, y the first times y the second is y to the third. I'm going to leave my x to the ninth alone. Down there in the denominator and combine x to the second times x to the fourth. You're going to add those powers over multiplication, so you get x to the sixth. And I've got a y to the third. So notice what happens with the y's. Y to the third divided by y to the third. You would subtract your powers. You get 3 minus 3 there, which is 0. And y to the 0 will just give you a 1. So we don't have any more y's. X to the ninth divided by x to the sixth. Subtract your powers and you get x to the third. There's more at the top, so an x to the third up here. So 45x to the third over 8. So our learning target here was to simplify expressions with negative exponents, and that's what we did.